Hello again, my name is Richard, if you don't remember me from the previous videos. Today we're going to learn about how to use the National Instruments USB DAQs that we'll be using. We have two types of DAQs. We have the 6008 and the 6009 USB DAQs, like this, from National Instruments, and we're going to learn how to connect everything and hook it up into the computer. So the first thing you need to do to use this USB DAQ is you're going to connect the one end that you usually see on a printer into the DAQ. And then you're going to take the other end, it's a USB cable, and you're going to plug it into a USB port on these computers. Once you have that, then you can hook up whatever you need to hook up to the DAQ. You'll see a port that says AI0 plus and AI0 minus. What you're going to do in the plus port, you're going to put the positive input, and on the minus port, you're going to put the ground input. And you're going to take the set screws on the top here that correspond to those ports, tighten it down, and then you can start using the DAQ in LabView. Okay, the first thing you need to do once you hook up your DAQ is you need to start LabView. Once you start LabView, this menu will pop up. You can choose blank VI, you can choose empty project, VI from template, there's more you can look at, and then you can also browse for existing files. So we're going to choose blank VI, and I'm going to put the block diagram in the front panel as half the screen so I can see both. To use the DAQ Assistant or to use the DAQ, we use the VI block called DAQ Assistant. To get to there, you go on your block diagram, right click, go to Express VI, and then Input DAQ Assistant. And when you place it in there, it takes a minute for it to initialize. Once it's finished initializing, a dialog box will show up, as you see right here. And then we have two options. We can acquire signal or generate signal. So we're going to acquire signal. We're not going to use the generate signals. And we're going to choose analog input, but you also have counter input, digital input, and TEDS. We're going to use the analog input, like I said. And when you go here, you can see the different types of signals you can choose from. We're going to choose voltage, and we're pretty much going to be using voltage throughout the whole semester. Once you select that, and then you come to a window that chooses the device. Sometimes it will search and then display it, but I have a USB DAQ 6009. And I can select the proper channel input I want to use. So I have AI0 is the main port I'm going to use. It's the first port you can use, and I'm going to select that and hit finish. You can also select multiple channels by clicking shift or control while you select them, and then you can select multiple channels as it said below there in that same window. Now once you have it, once you complete that window, this window will show up, and in this window is where you set all the properties of your DAQ that you're going to be using to take data. So at the top here, you see this picture area here, this graph here. You can click Run, and it will give you a sample of what your data will look like using the settings you have. Now, since my DAQ is not hooked up to anything, I'm just getting signal noise. That's why the scale on the vertical bar is in millivolts. Now you can also go to the Connect Diagram box, and what this does is based on your current settings and what channel you're using, it shows you how to connect your DAQ. So this is for the analog side since we're using analog, and then you can see the ports you connect to. So this red line is the positive channel, and this yellow/orange line is the negative channel. So that shows you how to hook up your input properly. Now if you don't know how to hook it up in a certain configuration, or you don't know what channel you're using, you can always go to this and it'll show you how to use it. It also tells you which point and which pin to use. Now that we're back on the Express Task section, we can talk about a few other things. You move the graph up, and so you can see this bottom section here. We can see that we have voltage here. That's our current signal that we chose. You can click this button here, and this button changes the channel that we're choosing. So you can change to AI0 if I wanted to, AI2 in case I wasn't using those two values, and if I wanted to, I could change to that in case you haven't used it before. Now you can also remove channels by hitting the X here. I can remove the highlighted channel by hitting the X here, or you can also remove it at the top. I can also add a channel here in this menu by clicking the plus sign and choosing the one that I want to use. Now the next thing we need to know is on the signal input range, we can choose the full scale range of the DAQ. So this is the maximum value and the minimum value the DAQ will read. And that is where you would change that. So say right now I have plus or minus 10 volts. So if I measured a signal that was 11 volts, it wouldn't be very accurate because it's outside of that range. So when you choose this full scale range, it determines the resolution of the DAQ. So this is where you would want to change it. So say I will only get a voltage signal from 0 to 10. In that range, I only want 0 to 10. So I would change my minimum to 0 because I know I'm only going to get a range between 0 and 10. Now here it tells you the scale units, and this scale unit's based on your channel input. The next thing that you would need to know is the terminal configuration of the DAQ. So we're using AI0 plus and AI0 minus this time, which is a differential. So a differential takes the voltage measured between the two, AI0 plus and AI0 minus. It's the difference between those two ports. It measures those two voltage differences and displays it. Now RSE is another type of terminal configuration, and instead of using AI0 plus and AI0 minus to get the signal, it uses AI0 plus and the ground. So it's measuring the difference between the voltage from the AI0 plus and the ground of the DAQ. The last thing that you need to know for your DAQ in this section is the acquisition mode, the number of samples, and the sampling rate. So N samples is basically tells you run for this certain number of samples and stop. So I'm running for 1,000 samples at a rate of 1,000 hertz. So it's going to stop after it does that, after it satisfies that condition, which is 1 second. So every time I click run, it's going to collect data for a second and stop, and it's not going to continuously run that data. So every time I want to collect more data, I would have to click that button. Now there's another type of acquisition mode, and that's continuous samples. This continuous samples mode basically means that it's going to collect data continuously at the number of samples and the rate that you have defined. So if I have a rate of 1,000 samples, 1,000 hertz, and then I have a number of samples of 1,000, every second it's going to update. So it's going to collect data for a second, display it, collect another set of data, display it. So it's going to have a delay of about a second reading that. And then you also have one sample on demand and one sample timed. We're not going to be using these. We're basically going to be using N samples and continuous sampling. Right now I'll leave it at N samples. The last thing you're going to want to figure out about this is under advanced timing, you'll see this additional timing settings, timeout. This basically tells you, kind of like a web page, if you don't get a response after a certain amount of time, how long to wait before you tell it to give it an error. So here, it times out after 10 seconds. So if I try to take samples longer than 10 seconds, it's going to give me an error saying the DAQ is timed out. It will also give you an error if the DAQ is trying to collect data but doesn't get anything and doesn't display anything. It will give you an error there too. So say I wanted to collect data for 30 seconds, I would change this to like 40 seconds so that the DAQ won't time out. So once you have all your configurations and everything set up correctly, you hit OK. And then it's going to build the VI. And once it's done building the VI, you got to give it a minute here. And once it's done building it, it'll let you know by basically telling you it's not processed anymore. So you see this window coming up saying it's building it. Once this window goes away, then you'll be able to finish creating your VI.